So welcome back to the third installment of Statistical Methods. In Lecture 3, we will be covering Chapter 2, at least the first part of Chapter 2, which looks at central tendency. But before we get into that, I just want to point out that we have a homework assignment due on September 7th. Now, this will go live on my Stat Lab on Monday, August 31st. And there are a few things to keep in mind. So in regard to attempts, you have a unlimited number of attempts on any problem. So that means that you can do the problem over and over again until you get it correct. And in terms of due dates for this assignment and similar assignments going forward, they will always be due before midnight, so 11:59 p.m. on the due date given in the course calendar. So last week we talked about distributions. So we've seen how frequency tables and histograms can help us quickly get a sense of what a distribution looks like. So a distribution is, again, a collection or group of scores. So we talked about how distributions can have various numbers of peaks. So we talked about uniform distributions and multimodal distributions, distributions with multiple peaks. We talked about symmetry versus skewness, where along the x-axis most people are scoring, and the amount of variability or dispersion of scores in distributions. So why do they matter, distributions? Well, inspecting these histograms or frequency tables for variables, which you've included in your study, is important because it can give you a quick intuitive sense of how your entire sample is scoring on the variable in question. And it also allows us to detect outliers or unusually high or low scores. And finally, many statistical tests that require variables to be distributed a certain way. Rather, many statistical tests require that variables be distributed a certain way. So many statistical tests, for example, rely upon assumptions that the distribution of scores that you're applying these tests to approximate the symmetrical normal or bell-shaped curve. And if you violate these assumptions, these statistical tests won't work in the way they are supposed to and can give you faulty information. So analyzing your distribution before applying a statistical test can help ensure fidelity in your results. Now, beyond tables and graphs, though, researchers usually want to put exact numbers on certain pieces of information about a distribution in particular. So central tendency of a distribution is one of these pieces of empirical information that researchers often apply to understanding a particular distribution. And central tendency measures give us a sense of what a typical score in a distribution looks like. Or, in other words, around what value are most people scoring on this particular variable of interest. Now, another statistic that researchers often want to get a sense of for a distribution is the variability of a distribution. Or in other words, how spread out or dispersed are these scores from this measure of central tendency. So this week we're going to learn about the various statistics that communicate this information, including how to calculate them in Excel and what exactly they tell us about a distribution. Now, based on the description I've just provided of the statistics of central tendency and variability, do you think these are descriptive statistics or inferential statistics? Well, generally speaking, and in the way that we're going to use it for this course, these are descriptive statistics. So we're not necessarily making inferences about a larger population of interest. We're simply describing the obtained scores for our given sample with measures of central tendency and variability. So why do researchers focus on these two metrics specifically? Well, they are arguably the most important and informative features of a distribution of scores. So for example, I would probably come to believe very different things about class performance and follow up with very different actions given these four following possibilities. So if the average score on an exam is a 95, but there's very little variability in scores, or if the average is a 95, but there's a lot of variability in scores. Now, if the average is a 65 with very little variability in scores, or if the average is a 65 with quite a bit of variability in scores. So in this example, central tendency tells me how is this class as a whole performing, whereas variability tells me how much do my students differ from one another in their performance. So if I have a high class average, I get a sense that the class is doing very well on the whole. But if I have a low class average, I get a sense that the class is doing poorly on the whole. Now, if I have high variability, that means that grades are very spread out. So I'm dealing with a wide range of abilities. Now, if I have low variability, all of the grades are very similar, and I'm dealing with a narrower range of abilities from my students. Now, we'll begin by learning several ways to conceptualize central tendency, or the value that scores seem to cluster around. And 3 measures of central tendency that we'll talk about are the mean, median, and mode. Now, the mode is simply the most commonly occurring value in a distribution. So in other words, the high point of a histogram, or the value with the highest frequency from a frequency table. So if a sleep researcher asks 10 participants to record the number of nightmares they have and can remember over the course of a week and obtains these following scores, I'd like you guys to figure out what the mode would be here and pause the video. Okay, so from this set of scores, it seems that the mode would be 2, since this score arises 5 times in this distribution. Right, so the mode is simply the most prevalent score in a series of scores or in a data set. So what are the advantages of using the mode as a measure of central tendency? Well, the mode is not going to be really affected by extremely high or low values, so outliers won't pull up or push down the mode. Now, modes can also be used with qualitative or categorical data. Now, disadvantages to using the mode is that the mode isn't based on all of the values in a distribution. It's really only based on the one that appears the most. Now, another disadvantage is that data will sometimes have more than one mode. Think about multimodal distributions. So my recommendation is to only use the mode for categorical variables. For example, if the variable was what type of pets do you have? If most respondents reported having a cat, this would be the mode for the distribution. Now, another measure of central tendency is the median, or the middle score when lining up all of the scores from lowest to highest. So steps for finding the median are as follows. So 1, line up the scores from lowest to highest. Figure out how many scores there are to the middle by adding 1 to the number of scores and dividing by 2. And then you simply count up to the middle score or scores. Now, if you have 1 middle score, this is the median. That will be the case if you have an odd number of scores in your distribution. But if you have an even number of scores, you'll have 2 middle scores. And in this case, the median is the average or the mean of these 2 scores. So what is the median in our nightmare data set? So here these scores are ordered from lowest to highest. And we have 10 scores, so we're going to add 1 and divide by 2 to find that middle score. So here, since we have an even number of scores, we're going to have 2. That's why we have a decimal. So we're going to look at the 5th and 6th score. So that's these 2 right here. and take the average of the two. So that would be 2 plus 2 equals 4, divided by 2 equals 2. So the median in this example is indeed 2. Now, what are the advantages of using a median as a measure of central tendency? Well, like the mode, it is not as affected by typical, or rather atypically, high or low scores, or outliers. And it actually describes heavily skewed distributions better than other central tendency stats, such as the mean. But a disadvantage is that, like the mode, it's not based on all of the values in a distribution, but simply the middle values when lined up from smallest to largest. And that being instead, it is more heavily affected than the mean by minor changes to the distribution, so such as the addition of a few scores. This could vastly change the median. Now, the recommendation here is to use the median when there are outliers or if the distribution is heavily skewed. So an example of when a mean might not be best representative of central tendency in a distribution is when looking at income data. So the median is often used instead of the mean when dealing with income data because we don't want our notion of what is typical in terms of income being distorted by the super rich. And this brings us to mean. So the mean is simply the average of all of the scores in a distribution. So the sum of all of the scores divided by the number of scores. So in that nightmare data set, if I add up all of those scores and divide by the total number of scores, which is 10, we see that the mean is 2.8. So on average, people have 2.8 nightmares in the last week. So the mean visually can be thought of as a balancing point of a distribution. So here's an image of a distribution, basically a histogram made up of blocks on a balanced board. And this mean of 6 is where that board would balance. Now, the biggest advantage to using the mean is that it utilizes every score in the distribution. But disadvantages are that it can be heavily influenced by extreme scores. So if yearly salaries at a company in thousands of dollars were as follows, the mean salary would be $52,000. But this isn't really a good representation of what the typical employee is making, because those really extremely high salaries are pulling up the mean far away from the median, which would be $15,000. Now, in social science, we primarily rely on this mean to describe central tendency of our variables. And this is because it utilizes all of the information available. So that means it utilizes every person's score and weighs all scores equally. Now, outliers are expected to be rare in social science data, but when they're present, researchers will typically make informed decisions as to whether or not they should be removed or kept in the dataset for subsequent analyses. Now, you might be familiar with this formula for how to calculate a mean. So the mean equals the sum of scores divided by the number of scores. But we're going to rely on a more formal statistical version of this formula, using terms that will generalize beyond this formula to other things we will learn in this class. Now, in statistics, the mean is represented as in uppercase M, and notice the italics which most statistics use. Now, the formula for the mean can be expressed as follows. Mean equals sigma x divided by n. Now, in this formula, sigma, that Greek symbol there, is the summation symbol, and it tells us to sum up the result of whatever operation follows for every participant. Now, x, which follows sigma, is one individual score on some variable of interest. And finally, n is the sample size, or the number of scores or number of participants in a data set. Thus, all this equation is telling us to do is what we've already been familiar with for quite some time. Take the sum, sigma, of all x's, which are the participants' scores on some variable, and divide this by n, which is simply the number of scores. Right, so the mean equals the sum of the scores divided by the number of scores. Now, sigma is going to appear in several formulas throughout this class, so let's do some more practice problems to make sure we understand how this works. Now, when you see sigma, it basically means do whatever mathematical operation follows for every single score in the data set. That's the important piece of information there. And then add all of those numbers up. So imagine if I were to ask 5 students in this class for their age and get the following scores. Now, I would like you to pause the video here and solve the following using this data set. So now we will quickly go over the answers to these 3 questions. Now, the first one is simply a summation of all of these scores, which equals 93. Now, the second one here, we add 5 to each individual score and add up all of those additions, which equals 118. Now, in the third one, which is perhaps the trickiest, we subtract 1 from every score and then subsequently square it and then add up the result of each of these. And that leaves us with the sum of 1,554. So now I would like to do an in-class demonstration, and then I would like you guys to try to replicate what I've done yourself. I will make this data set available. So on the course page in the content, or rather in the collection of lecture materials for this week is a spreadsheet titled Country People. Now these data are a response to the question, would you prefer to live out in the country with not many people around on a 1 not at all to 7 extremely scale? And through working with this data set, we'll learn a few ways to calculate the mean using that formula I presented earlier for this data set in Microsoft Excel. You could also do this in Google Sheets or LibreOffice. Okay, so now we are in Microsoft Excel and we are looking at that spreadsheet, Country People. So this is a data set that was collected from students a few semesters ago. And again, the question here is, how much would you like to live in the country with not many people around from 1 through 7? So lower scores mean I would not like to live in the country with few people around. Higher scores mean I would like to live in the country with people around. And we are going to use 2 formulas to calculate the mean. So the first one is the long form. And again, remember, the mean is the summation of all of these scores. And that would be divided by the number of scores in the data set. So here there are 32 scores. And in the first column here, we have the subject ID. So that is not the variable of interest. The variable we're interested in is this country variable, which is responses to that question I mentioned earlier and the one that is posted in the slides. So to calculate the mean for this, we start out by typing in an equal sign in the cell where we are going to want to have our mean. And we're going to write the word sum. And now we're going to indicate the vector of scores we want to be summed up. So starting with the first cell, that is B2. And since we want all of these scores, we're going to go all the way to B33 by using a colon sign and then entering B33. And we're going to want to close our parentheses here and use this backslash to indicate division. And since we want the number of scores to be in our denominator here, we're going to write count, which is an Excel function that will give us the number of scores selected in a particular range. And we want the same range of scores, B2 through B33. And close parentheses. And if I hit enter, this should return the mean. So on average, people are right around a 3 on a 7 scale of wanting to live in the country. Now, a much quicker way to do this is by using the average Excel function. So always start your formula with an equal sign, type the word average, open parentheses, and include your range. So that would be B2 through B33. And once we hit enter, we should see the same mean returned. Now I would like you to replicate what I've just done, so take some time to pause the video and do that for yourself until you get these values. So now that you have done that, I would like to reiterate some Excel basics. So rows are denoted by numbers and columns are denoted by letters. Now to refer to a specific cell, like you just did in that demonstration, so that is one box containing one value, you use the letter/number combination of that cell. So for example, A24, C13, E89. Now, as you saw in the demonstration, any mathematical function will begin with the equal sign. Now, for any further function that you want to apply to any array of cells, so that is, again, a range of values going across a row or column, going across a row or down a column, more specifically, you use the first cell, colon, last cell. So for example, if I want all values from range A1 through A40, I would enter A1, colon, A40. If I want the same for B5 through B35, I would enter B5, colon, B35. Now, Excel functions are, as you might have seen, mathematical operations of various kinds that will come after the equal sign. So we learned 3 just now. So we learned sum, which gives you the sum of the values specified, count, which gives you the number of data points for the value specified, and average goes straight to giving us the mean for the values specified. Now I'm going to give you a second in-class problem here, and you could do this in Excel, and you actually don't have to submit these through Blackboard. I will remove that from the slides, so keep that in mind. This is just for your own practice. Now, so here are 10 random students' answers to the question, are you made uncomfortable by loud noises? Asked in a questionnaire handed out on the first day of class a few semesters ago. And these scores are 5, 3, 1, 4, 4, 2, 1, 2, 3, 3. So I'd like you to go into Excel and calculate the mean, median, and mode for this range of scores. Now, once again, you do not have to submit this over Blackboard. This is simply for your own practice. Now, I'd like you to pause the slideshow here and do this just to get some more practice with calculating measures of central tendency. Now, that concludes this particular lecture. For Wednesday, I would like you to continue reading Chapter 2 and begin homework number 1 on My Stat Lab. Thank you very much and have a good tomorrow.